Hey guys, this is Patrick from STH, and today we're going to talk about this server right here. Now, this is the Inspur NF5280M6, and this is really Inspur's 2U dual socket Intel Xeon just mainstream server platform. And specifically, the plan today is going to be something that's a little bit different from what we normally do. We are, of course, going to go through the hardware. We're going to go look at a lot of the different hardware options that we have, talk about some of the ones that we don't have in the system. There's a lot of flexibility actually in this platform. And the other thing that we're going to do, and I think this is really fun, is that we actually have servers from Dell, HPE, Inspur, and Lenovo. And so my thought was that this quarter, let's go look at the servers from the top 4 largest server manufacturers in the world and actually go talk about some of the differences. So not only are we going to go through the hardware of this Inspur server, but I also want to talk about some of the design elements and just kind of why this server is built the way it is and how that's kind of different from some of the other servers on the market. Inspur actually does something that is quite a bit different than some of the other server vendors. So I figured let's kind of talk about that and kind of show you what's going on. So with that, let's get to the hardware. So let's start with the front of the system. Now what you can actually see is that we have a 24 bay system here. That's pretty standard on a 2U form factor like this. Now these 24 drives, they can be SATA, SAS, NVMe. You can choose basically what you want in this and mix and match. So Inspur actually has quite a bit of configurability there. That's pretty standard actually in the space. And just real quick, we're going to note the fact that this has on the rack gears all your LED status lights, power buttons, and then you also have things like your USB 3 ports, which is kind of nice in this generation. And also you have VGA port. And what that allows you to do is actually go bring your cart into the data center and service the system if you have to actually go do hands-on with it and just kind of hook up a KVM card or something like that. You can actually do that from the cold aisle instead of having to stand behind in the hot aisle, because the hot aisle is it's hot. Okay, so flipping to the back of the chassis, what you're basically going to see is that this is actually called the 8 PCIe chassis. We're going to get to what that means in just a second. But what this really is you can see that there are 3 stacks of full height PCIe risers here. And so we get, a 3, 3, and a 2, and that's basically where we can go put our full height PCIe slots or PCIe cards. Now the server that we have only actually has one of those 3 riser slots that's actually populated. The other 2 are not populated in the system, which is actually kind of common that you see in a lot of server vendors. They just don't populate the extra, riser if you're not going to use it. And that's basically what's going on here. So normally there would be risers that would sit in this middle section, and we're going to show you where those connect when we get to the internal overview. But that's basically the idea behind this 8 riser or 8 PCIe slot solution. But saying that there are only 8 PCIe slots on the back of the system is actually kind of not true. And let's kind of talk about one of them right now, which is that in this configuration, there's actually in the rear the option to have either M.2 or EDSFF E1S boot media. And so if you want to just have 2 extra drives or something like that, and you just want to use them for boot media or something like that, you can actually do that here. And one of the kind of cool things I think about this is the fact that by having them on the rear, you don't actually have to open up the system and get inside, tear it apart, and be able to go replace an M.2 SSD or an E1S SSD. You just have them and they're serviceable from the rear of the chassis. And so if you ever did have to, SSDs are super reliable, but if you did have to go and replace one, it's way faster to do that if you don't have to open up the system and go fiddle inside. Now this is definitely a trend that we are seeing in the server industry, but not every vendor does this. And so this is definitely a differentiator. Now let's move down to the bottom of the system and really kind of talk about some of the IO that you have. Now the first thing that you're going to see, and let's just get this one out of the way first, is that we actually have an OCP NIC 3.0 slot. Now here's a kind of look at it in the inside of the server, just so you can kind of see and you kind of know what's going on here. But what this actually is basically the industry standard. The OCP NIC 3.0 is the standard in the industry at this point for high-speed NICs. We're still going to have PCIe cards because there's usually limited OCP NIC 3.0 slots, but at the same time, these things are absolutely a force in the industry because all of the hyperscale clients or all the hyperscale guys are out there and they're actually using this OCP NIC 3.0 form factor. And so because all the hyperscalers are, a lot of these server vendors are also adopting it because it doesn't really make sense to go and have your own proprietary LOM anymore. It's just something that That's old. Nobody really would want it anymore. And so now we see these OCP NIC 3.0 slots in the vast majority of servers, frankly. And so what we actually have here is we have a Mellanox, now NVIDIA ConnectX. So this is a dual 100 gig Ethernet OCP NIC 3.0 card, and that's in here, and that's what's basically providing the high-speed networking in this server. You are going to see that there is a cutout for, I guess, two, these would be like SFP plus cages, and what you can get in this server that ours does not have as an option is you can get the Intel X710 on the actual motherboard itself. Now we're going to show you the pads on like where the components like the NIC and also the SFP cages are going to be as well. But, you know, they're just not populated in this because the idea of this is not using 10 gig Ethernet. That is something that we are seeing is a much bigger trend that folks are saying like, hey, why would I even go put 10 gig Ethernet in a system? Why would I not just jump directly to 25 gig Ethernet? And so it's just something that, you know, is definitely in the server and that you could get, but we just don't have in this. Rounding out our standard IO, we actually have two USB 3 ports. We have a out-of-band management IKBM port, and then we also have a VGA port. So you have basically the USB and VGA both on the front and the rear of the system. The out-of-band management port is definitely important. We're going to talk about that a little bit later in this. The key here, though, is that if you do not get that X710 option, you do not get onboard networking. You're going to be using either cards or the OCP NIC 3.0 slot for your networking. There are a lot of server vendors that they're doing this these days just because onboard networking, if you're putting like 1 gig on there, a lot of data centers are saying like, hey, having 1 gig networking just doesn't even make sense. And at the price difference these days between 10 and 25 gig Ethernet, I'd rather just do 25 gig Ethernet. So that's kind of why we are seeing that we're starting to see, I guess, fewer onboard NIC options, and we're starting to see more OCP NIC 3.0 in server. And while we're here, let's just get to it. We actually have two 1.6 kilowatt power supplies. Now, Inspur actually offers a pretty wide range of power supplies. I mean, you can get all the way down to, I think, like 500 watts and all the way up to like 2 kilowatts. There's platinum power supplies or 80 plus platinum. There's 80 plus titanium power supplies as well. And so you have a pretty wide range in terms of options for whatever you want to go put in the system. And we just have the 1.6 kilowatt option. So that's what we have. Now, something that I do want to talk about really briefly here is just the fact that there are a lot of options if you do want to customize this. Now, we have a 24 bay front and a 8 PCIe riser rear, and that's kind of, you know, what we really have in the system. But there are a total of 5 different front options and 4 different rear options. Now, of course, we don't have them all, but I just want to flash this up real quick. So as you can imagine, there's actually a lot of variability that we're not going to get into in the system, but I just kind of want to talk about it. And this is something that a lot of vendors do, especially a lot of the higher end vendors. They have like a model, and then you're going to see all these different options that you can get. Some other vendors like have a different specific model for like each of these combinations, and then the SKU stack gets just kind of crazy and it becomes pretty hard to like kind of know unless like you can decipher model numbers and stuff like that, like what's going on. So I actually kind of like this approach to doing your server models, and all of the large vendors do that. Okay, so that's enough of that. Let's get to the inside of the system, and specifically, let's start with that storage that we talked about. Now, you'll remember that we have that 24 bay configuration, and we can do NVMe, we can also do SAS or SATA, and that's really the idea behind this configuration. Now, something that you are going to notice that is the backplanes. There's actually 3 separate backplanes. So each of the 8 drives or sets of 8 drives has its own backplane, and you can swap those out. This modularity is something that we definitely see in a lot of hyperscale servers, and so it is something that is good that we see from Inspur here. It used to be, by the way, that to go and replace a backplane in a server was just an absolutely terrible experience. I mean, it's like a whole bunch of screws, they're hard to get to and all that kind of stuff. But now these days, you know, basically you have a thumb screw and you can just pop these suckers in and out real fast. And that is definitely a cool feature on new servers. Now, there are these 4 fan units, but let's get to in front of these 4 fan units first, because there's actually these, like, I think they must be like aluminum or something like that, but this little honeycomb structure in front of the fans that's directing airflow from, you know, the front of the system to the fans. And, you know, this is just something that we don't see on a lot of servers. Normally it's just like a fan grate and then, you know, there are the blades. But this is something that's a little bit different. And I just kind of thought that was really interesting. I don't know why, but you just don't see it on many servers. And of course, as you would expect on a high-end dual socket server these days, you have hot swap fans, which, you know, kind of look like this. And you just basically pop these things out and you're ready to go. It's super easy process. Inspur has a nice system and it mates really easily. So it's definitely something that's easy to service, but it's a fan at the end of the day. So let's keep moving. Okay, the next thing that you're going to see in the server is actually just this kind of fan shroud. And here's the fan shroud right here. You kind of see it. But the basic idea here is that this is actually a hard plastic unit, which is actually kind of nice. I actually really like this one. It was super easy, by the way, to pull out. Some of these ones, you had to do a lot of like latches and stuff to get out, and had to line things perfectly to get in. But this one actually just slips in and out really easily. And so I thought that was actually kind of cool. But this thing, aside from directing airflow, actually has a couple of other features that I want to talk about. The first one that I just kind of like is the fact that you actually have little labels on the air shroud, and they actually have little windows and they tell you which DIMM is which. So it tells you which DIMM it is and which channel it is. And so if you do get an error message, because let's face it, memory modules fail in all servers. And so you basically can go in and figure out which memory module you have to go service really easily, because you have a little window that tells you and labels everything. Super easy. Now, something else that you're going to see is that there's actually a total of 4 sets of Velcro straps that sit on here. And you might be wondering like, hey, what the heck are those for? Well, those are actually labeled, and we don't have this configured in our system, but they're labeled as super cap. Now, the reason you have super caps in systems is typically when power fails, you have systems that may need to go and dump stuff or dump data from RAM to some kind of non-volatile memory, usually NAND. And usually in that process, the 2 places that you see it in servers are on a RAID controller. So that's kind of like your battery backup unit or your cap on your RAID controller. But the other place that you do tend to see it, especially in servers these days, is really with NVDIMMs. And so these sit right above the DIMM slots. And so if you had an NVDIMM cable, you definitely would not have a super long run for your power connection. And so that's just kind of interesting to just kind of see that there are like specific Velcro straps for super caps in the system. I don't know, I just kind of thought it was a cool little feature. And as cool as that plastic cover is, what you really want to see is what's below that. Now, below that, we actually have 2 Intel Xeon scalable, or 3rd generation Intel Xeon scalable Ice Lake processors. This system can actually take up to 270 watts, which means that you can put all the way up to an Intel Xeon Platinum 8380, which we did put in this system, and it definitely worked. And so you can definitely tell the fact that this is a higher end system because you don't have any, TDP limitations. You can go through the entire range and cool it in the system while also cooling all of your PCIe cards and front storage. So that is a, kind of a little bit of a differentiator in this generation, especially, you see some kind of cost optimized systems that can't go all the way up to 270 watts, but this is definitely one that is focused on being able to provide, the entire range of processors in a single platform. I will note just real quick here that we do actually have a couple videos where we've started to look at some of the acceleration. So specifically things like the crypto acceleration, but also some of the AI acceleration in those Intel Xeon scalable Ice Lake processors. And so we have those videos on YouTube. We can link those in the description. Now, each CPU has a full set of its 8-channel memory with 2 DIMMs per channel. This also supports things like Intel Optane DC persistent memory. So if you wanted to have the PMEM 200 series, you can put that in the server as well. And so the ability to have 16 DIMMs per CPU, 2 CPUs, means that you get a total of 32 DIMMs, half of which I think you can actually have as Optane. And so you can get an absolutely huge memory footprint if you want to in the system. And another really small feature, but one that I really think is super cool, is that you can see on the side of the system or on the side of the CPUs and memory that there are these little channels that actually take the cables that you need to kind of pass from the rear of the system to the front of the system, and they actually put them neatly into these hard plastic channels. And you might ask like, hey, what is the big deal about having something like that? But that is exactly what allows Inspur to make this really well molded and very easy to take in and out fan shroud cover thing, is just the fact that these things are in a predictable shape. Now, when you see a lot of vendors, they either just pass with straps or they'll just pass cables through this. And then you kind of have these kind of weird fitting air shrouds or something like that. And this does not have that little tiny feature, but it is something that is a differentiator. And I guess let's just kind of finish up that theme of airflow. And really what you can see is that there actually is a channel that goes on the left side of the chassis that actually channels air from the fans, and then it goes out of the rear storage. And specifically here, this is because we have the M.2 option. And so you can actually see that we have that channel right here. Now, directly behind the CPU memory, we have 4 features that I just want to cover super quickly here. First off, we have 2 just kind of standard SATA 7-pin connectors. So those are just kind of normal. You don't get a ton of them in servers anymore. You're also going to see that we have power connectors there. You're going to see that we have 2 SD card or micro SD card slots, and those are really for both the BMC and the system. So this has those. And then the other thing that this has, which I think is kind of cool, is it actually has an OCP mezzanine slot. So if you wanted to have, instead of a RAID controller or an HBA that goes on, into a PCIe slot, you can actually still put one on the inside of the system. So what that practically means, and it's actually kind of important, is that for like the 11 PCIe configuration, you can have those 11 PCIe slots that you can actually use, but you can also have the OCP NIC slot, and you can also have this OCP internal slot, and that gives you a little bit more connectivity than you would normally have if you didn't have this. And so it's just kind of nice. And also just the big thing here is that Inspur is not making like their own proprietary one. They are using an OCP form factor, so it is something that is a more open form factor. Oh, and just real quick, there also is a TPM 2.0 module here. And then moving to the very rear of the system, what we're going to see is that we have that OCP NIC 3.0 slot that is populated with the Mellanox 100 gig adapter. Then we also have a couple other things. You can see the riser that would go to that kind of middle riser configuration that we don't have, but that's kind of where that big riser slot is. In the center, you're going to see our Lewisburg refresh PCH that's going to be under this giant heatsink that's there. But there are actually a couple other chips here that we should talk about. The first one that we want to talk about is the ASPEED AST2500 BMC. Now, Inspur uses kind of more of like an industry standard management stack. Now, they definitely have some customizations for Inspur, but the idea is that really Inspur is saying like, hey, we don't really want to have like a super proprietary thing like the iDRAC ILOs or Clarities of the world. This is very, very close to what you would call an industry standard one. And so that's really the reason that Inspur is using the ASPEED AST2500 here. That is used by a ton of hyperscalers, and it's just kind of like that's basically the big one in terms of baseboard management controllers in the industry. It's by far the most popular. And then the other big chip you're going to see is the Intel FPGA. And that's really just kind of more for platform features. Finally, we get to the riser, and our riser basically is populated with 2 full height slots, although we have low profile cards in there. And then basically here on the top, we have our HBA RAID controller. And then on the bottom, we have our networking. And so, this is kind of something that you saw in the back that we had those like SFP 28 cages. And that's kind of really where you would put like a 10 gig or a 25 gig NIC. Specifically, you could get those, I guess, 10 gig ports that are optional in the system that we do not have. But on the other hand, a lot of people just either don't really want to use the Intel X710, they want to use something different. And so if you want to use a different NIC, or you want to use a 25 gig NIC, the onboard networking really doesn't help you. And that's why you would put something in this slot right here. And that still gives you the large full height slots for the rest of the system. We don't have them populated, but of course you could put 6 full height cards in the rest of the system. And that's basically how this is laid out. Okay, so in terms of performance, let's just kind of go through this real quick. Something that you're to see is that we basically got similar performance to what we would expect from the Platinum 8380s, which is really the high-end SKU. But we also tested a couple other SKUs in the stack, and we saw pretty similar in terms of, our overall performance in this system versus what we would expect from a baseline like super tuned system. So it is definitely showing that Inspur has all the performance that you would expect from the Intel Xeon scalable platform. That's exactly what we're showing here. Frankly, Inspur is a huge vendor, so you'd expect absolutely nothing less. In terms of power consumption, if you're going and doing things like you're hammering this with AVX 512 and you're kind of really going at it, you can definitely get this thing over 1 kilowatt. And there's definitely more configuration. I mean, you could definitely put GPUs or, other NICs and accelerators, DPUs, all kinds of things in the system. So it's definitely one of those ones where, yeah, we could definitely get over a kilowatt on this configuration, but there are definitely other configurations that are out there. So while we have the 1.6 kilowatt power supplies that are in this system, again, remember that they do scale all the way down to like 500 watts all the way up to 2 kilowatts. And so there is a pretty, I guess, wide variance in terms of what Inspur is supporting. So I mentioned at the outset that we're going to talk a little bit about what are the differences between like this server and some of the other large server vendors. And I think that the real thing to me that stands out with Inspur servers versus some of the other ones is really just the fact that Inspur's server designs are really designed like almost like they're designing for a hyperscaler, right? So where you have the kind of some of the other solutions in the market that are like have proprietary management features or something like that. And some of those do have some good features, but I think what Inspur does that's really kind of cool is that they are are a large server vendor, but they still kind of stick to that kind of like industry standard. So you have things like you have OCP NIC slots. Instead of having a proprietary mezzanine for like storage, you have the OCP storage slot, right? So it's things, again, that these are kind of more the like open standards. In terms of the BMC, you don't have like a proprietary controller. You have the ASPEED AST2500, which is by far the most deployed BMC out there. Now, we're definitely going to talk about this more when we get to the other servers in this quarter, but I think the one thing I just want to leave you with is the idea that Inspur really likes to stay close to industry standards, or as close to them as they possibly can. Whereas you see some of the other large server vendors that kind of see, they try to build in a lot of proprietary stuff. Inspur really tries to keep things that are a lot closer to like open systems. And that's frankly because a lot of their customers or their large customers are large hyperscalers. And so a lot of their volume is being driven by, these kind of very large organizations buying tons of servers. And so you tend to see that Inspur server designs are really designed more for that kind of, hyperscale open kind of community rather than, being really proprietary. And by the way, if you just kind of want to see a little bit of the evolution of the platform, we also did do a review of the M5 generation of this server previously, and we'll link that in the description. And hey, if you like this, well, why don't you give it a like, click subscribe, turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching. Have an awesome day.